Alright, so you should have watched the short video on how to rewrite logarithms and exponential functions. Remember that rule from Algebra 2, first, last, middle. So we're going to start off with an example. This is what you were practicing in that previous video on how to rewrite them. So let's take a look at this one. If we want to rewrite it in logarithmic form, we would use that first, last, middle rule. So it would be log base 2 of 8 is 3. So notice, just moving the numbers around. So again, now if we want to write this one in exponential form, we do the exact same thing, but we write it as, we still use first, last, middle, but we would say 3 to the 4th is 81. So notice the pattern of the numbers. First to the last equals the middle. So if you try this one, say 2 to the negative 3 is 1/8. So that's something else we got to remember, is that a negative exponent does not mean a negative number. That means we have to move it into the denominator to make that exponent positive. So this becomes 1 over 2 to the 3rd, which would be 1 over 8. Alright, so one of the things that we're going to have to pay attention to is it might be easier to solve a problem in exponential form. So if we come across a logarithm that we're not sure how to solve, we should rewrite it in exponential form, because notice if we use that first, last, middle rule, we end up with 6 to the 2nd is x. So now we're done. X equals 36, right? Makes it super easy. So with this one, if we want to rewrite it, we have to start off and say, well, 5 to the y equals 1 over 25. Now, what we need to do is rewrite it so we have 5, like how can we write 1 over 25 as 5 to some power? Sorry, keep getting text. So, turn my phone off. So we would have what? 25 is 5 squared, right? But since it's in the denominator, we would need to write it as 5 to the negative 2, because that's what would make it 1 over 25. So now that the bases are the same, we're able just to say that, well, the exponents must equal each other. So now we can say y equals negative 2. And we are done. So with a problem like this, notice we're missing an equal sign. So all we need to do here is set it equal to something. And call it whatever we want. So set equal to y. So now we're going to rewrite it. 3 to the y equals 27. And now we just need to look at it and say, well, how can we write 3 to some power to be 27? And you say, oh, it's 3 to the 3rd. So now we can say, well, the exponents must equal each other since the bases are the same. So the answer would be y equals 3. Alright, so the last thing that we're going to talk about is today's that if we have a log with the same base on each side, we're able just to get rid of those. So pretty easy problems to solve, actually. So let's take a look at this problem. So notice we have a log base 3 on each side, so we're able just to get rid of those and have it be 4x plus 10 equals x plus 1. Then we can get all of our x's to one side, numbers to the other, and then we divide everything by 3 and we get x equals negative 3. So pretty easy equation to solve. So here's another example. So again, notice we have log base 8 on both sides, so we're able to get rid of those. And now we can do this a couple different ways. We could set it all equal to 0 and factor it. You can use quadratic formula. You can even use completing the square, but it would be kind of a pain in the butt with that odd b value. We're going to factor this one. So we say, well, what two numbers multiply together gives negative 14, but add it to be negative 5, negative 7, and positive 2. So then we just have to find the values that make those 0. So it would be x equals 7 or x equals negative 2. Alright, so now we do have a problem here because we're not allowed to have negative numbers here. Or so like in this spot right here. So if we plug in 7, we got to check our work. We got to make sure we get a positive result here, which we do. But if we plug in negative 2, notice we get a negative value here and a negative value here. So that's telling us that that negative 2 is not a solution. So you will need to double check your answers just to make sure you don't get a negative result there. Okay? All right. So why is this undefined? So hopefully you're thinking, oh, I need to rewrite that. Set it equals something. So 2 to the x equals negative 8, or 2 to the y, whatever you want to say. So hopefully it becomes more obvious. You're saying, well, you can't raise 2 to some power to make it a negative number, which is exactly correct. So that is impossible, because a negative exponent means you move the number into the denominator. So that is why we can't have negative numbers in that spot.